Now today we will learn vector addition in real sense. Suppose a vector A 2I plus 3j and another vector B 3I minus 4j. In two dimension there will exist only I and j, and if it is a three-dimensional vector we will have another term. Suppose it is 5k, suppose it is minus 3k. If you were asked to add these two vectors, it's a simple cakewalk. Just add them. 5i cap minus j cap plus 2k cap. Fine. Now, if a vector suppose 2 Newton is acting in this direction and another vector acting in this direction, 3 Newton, you have to add these two. To add these two, you have two options. You can bring this vector near here and you can also take this vector to here. So let's bring this vector here. Sorry, it should be parallel. If you bring this vector here, the length will be same, and this line must be parallel to this line, and this is your 3 Newton, and your resultant vector R, resultant vector is this. Suppose the angle between these two vectors is 60 degree. To get the angle, you have to produce this vector forward, and this is the angle between these two vectors, not this angle. Now you know the formula. So what will be this length? If AB is to represent 2 Newton, BC is representing 3 Newton, what will be the value of R? The value of R, that is called magnitude, that is 2 square plus 3 square plus 2 into 3 into cos of 60 degree, this Newton. So it is 4 plus 9 plus 2ab cos theta, 2 into 2 into 3, that is 2 into 3 into cos 60 degree is half, this much Newton. 2 gets cancelled. This is 13 plus 6, that is under root 19 Newton. So when two vectors, suppose this is an irregular body and 2 Newton acting in this direction on this body and 3 Newton is acting in this direction, and the net force, to get the net force, this is 2 Newton acting on this irregular body and 3 Newton acting in this direction. To get the net force, we must bring this 3 Newton here, what we did here. Or you can bring 2 Newton to here. You will get the same result. And you know, to get the resultant vector, you need the angle between the two vectors. And what is the angle between the two vectors? The angle between the two vectors is this. And if this is 60 degree, you have to put 60 degree here in the formula. The formula was discussed earlier. So 2 Newton and 3 Newton both acting on this irregular body. The net force acting on this stone is now root over 19 Newton. Very fine. Now the net force is acting in this direction. So you can see that net force is acting in this direction. This line must be parallel to this line, almost parallel. So this is the value of R. And this is not enough. I know that the magnitude of this R is root over 19 Newton. But this resultant is also a vector. So I must know the direction also. In which direction this vector, resultant vector, is acting. And to get the direction, we need another formula. If this R vector is making an angle alpha with 2 Newton, then I can get tan alpha. See, if I get the value of tan alpha, I can easily tell that at which direction the resultant force is acting. So I can find tan alpha, and if tan alpha is found, alpha is also known to me. The value of tan alpha is 3 sine 60 degree. 3 sine 60 degree divided by 2 plus divided by 3 sine 60 degree. Value of tan alpha is 3 sine 60 degree divided by 2 plus 3 cos 60 degree. So 3 into sine 60 degree is root 3 by 2, and 2 plus 3 into 1 by 2. So I got tan alpha, and if I get tan alpha, alpha is also known to me. Now I can tell everything about this resultant vector. The magnitude is 19 degree, root over 19 Newton, and it is acting at a direction making an angle alpha with 2 Newton. And the value of tan alpha can be obtained from this expression. So now I know the angle at which this resultant is acting and the magnitude. Now my answer is complete. Now my answer is complete. So this way we find the resultant and at which angle the resultant is acting. Okay.